Hi, this is Scott Allen, and this module is a look at the features inside the system.web.optimization namespace. The features inside this namespace allow you to optimize the load time of your pages by bundling and minifying scripts and style sheets. Bundling is the process of concatenating multiple files into a single download, while minification is the process of making the download as small as possible. In this module, we'll look at bundling and minification, see exactly what they do, why they're important, and along the way we'll improve the response time of a page that loads lots of scripts and styles. Let me introduce you to the scenario we're going to use for this module. Right now I have a very simple MVC application with almost no content inside. There is a home controller and there is an index view, but they do almost nothing but just render some simple text so far. But I do have the application set up with a lot of the infrastructure that I need later on. So if we look in the layout view, you can see I'm including Bootstrap. Bootstrap.css is a CSS framework you can include in a project to take care of your layout and typography. I also have my own custom style sheet, styles.css included, and the JavaScript library Modernizer. I'm including Modernizer at the top of this file because, as you might know, Modernizer is a library that detects features in a browser and in a few cases adds HTML5 capabilities to older browsers, and in order for it to work properly, it needs to appear before the body of the HTML document. And I'll also just point out a new feature in Razor here, which is that I can use the tilde in the source attribute of links and scripts, and Razor will find it for me and generate an app relative path. So this will work regardless of the URL in the browser, and this is a lot cleaner than what we did in previous versions where we typically use the URL helper to generate the URL. Here at the bottom of the layout view, I'm including some additional scripts that the application will ultimately need: jQuery, jQuery UI, jQuery validation, the MVC unobtrusive extensions for jQuery, and a templating engine called Mustache. I like it because it has a data binding syntax that is not obnoxious. And I'm loading all these scripts at the bottom of the page because I've heard it's a good idea to load your scripts as late as possible. That allows the browser to download all the content and get something on the screen while the scripts load later. Before I run this site for the first time, I'm going to go into a program called Fiddler. If you've never used Fiddler before, this is a free tool that you can use and download to debug and fiddle with HTTP traffic on your machine. You can just search the web for HTTP Fiddler, and I'm sure you can find the download link. I already have it up and running. I'm just going to go into the Rules section and go to the Performance section and check off two boxes here: Simulate Modem Speeds and Disable Caching. Disabling the browser cache will let me get more accurate timing measurements, and simulating modem speeds, this is a bit drastic, but it will make my optimizations easier to demonstrate because the numbers will be more dramatic. And in reality, there's a lot of people who run at modem speeds. My fancy 4G smartphone has more processing power than my first personal computer, but it spends a lot of time making 2G connections on the web and it feels very slow at times. So I'm simulating life with my cell phone provider, and I want to speed things up for myself. So with this all in place, let's go to Internet Explorer, where I already have the developer's tools open. You can open them with the F12 key, and I'm on the Network tab where I will click Start Capturing, and now let's initiate a request to the application. I'll come back later once all this is finished. Now the page is fully loaded, and it took almost a minute. I can tell by going to the detailed view on one of these requests and then switching over to the timings tab. I can see it was 56.1 seconds from the time we initially requested this page until the time the DOM was fully loaded, the DOM content loaded event fired, all the scripts and style sheets were in place. Almost a minute. That's slow. And if I go back to the summary view, the DevTools will also tell me there were over 897,000 bytes received for this page. So there are two ways we can improve the page load time. One is to reduce the number of bytes that we send to the client. You can see that jQuery was almost 250 kilobytes, jQuery UI was over 360 kilobytes. Those are our two largest assets. And if you already know about minified files, you might wonder why I don't serve the minified versions of these jQuery libraries, but we'll get back to that. So size is one problem we want to solve, and the other problem we want to solve is the number of downloads the client has to make. It's a little hard to see here, but some of the downloads needed to wait for other downloads to finish because every browser only makes a finite number of connections to a server. Internet Explorer was the most cautious browser. It would only allow 2 concurrent requests to a single server. Starting with Internet Explorer 8, Internet Explorer now allows 6 connections to a server. I can always verify that by going over to the JavaScript console and asking for the window.max connections per server property, and that shows me 6. So most modern browsers make between 6 to 8 concurrent connections to a server, but when you have 10 resources to download, this means that a few of them will need to wait for other connections to free up before they can start downloading. And if I look at one of the last resources to load, like mustache.js, and again go to the detailed view on the timings tab, it will tell me that it didn't start downloading until after 0.82 seconds after the initial request. So it took almost a second to reach the point where we could even start downloading this particular JavaScript file. And this is the scenario that ASP.NET Web Optimization set out to improve. We have a page that takes nearly a minute to load over a modem connection, and we're downloading nearly a megabyte of data. Let's see how we can improve this. In order to get started optimizing, I'm going to first need to install the Web Optimization package. That's because the MVC application project I'm working in was started with the empty project template, and the empty project template is pretty empty. It doesn't include stuff like the Web Optimization assembly. But if you start an MVC4 application with the Internet project template, then you'd already have system.web.optimization available and configured. If you're upgrading from MVC2 or MVC3, you can also install this package. At this time when I'm recording, Web Optimization is still in a pre-release phase, so I need to tell NuGet it's okay to install the pre-release software. In the NuGet console, I can do that with the -pre or -include pre-release flag. And one of the dependencies that will be installed when you install Web Optimization is a package called WebGrease. If you want to work at a lower level, I'll show you where the WebGrease tool lives. It's WebGrease that's actually doing a lot of the hard work behind the scenes. Let's get the Web Optimization bits installed by right-clicking on the project and saying Manage NuGet Packages. I want to make sure that Include Pre-Release is selected in this drop-down, and then I can search for Microsoft.ASP.NET.WebOptimizations. And I need to be a little bit careful because there are 2 packages available here. The first one, unfortunately, is a legacy package. The one that I want is Microsoft.ASP.NET.Web.Optimization. That's the one I'm going to install. You can see that one of the dependencies is WebGrease, and I'll show you where that lives as soon as this is finished installing. I can do that by right-clicking on the project, saying Open Folder in Windows Explorer. Let's back up one to the solution level. That's where NuGet packages get installed. If I look in here for WebGrease, then I'll see there's a lib directory. One of the files in this lib directory is actually a command line executable. If I open up a command line prompt and change over to that directory, then I can get a listing and I can actually run that. And if you look at the help file here, you'll see this is basically a command line tool for minifying files, validating files like validating JavaScript, building CSS sprites, output naming, all sorts of different features. You can include this wg.exe as part of your build process if you want to do some of this manually and have complete control over minification and validation at build time. We're not going to be going quite that low level. We're just going to use system.web.optimization here in our application by using some of the types and helpers it exposes for Razor. And the first thing we'll need to do is some configuration. To optimize our page load time, we have to tell the runtime what files we want to optimize. And we work with 2 types of files. We work with script files and style files, JS files and CSS files. And each type of file has an associated bundle class. There are script bundles and style bundles. So we build our bundles with the files that we want, and we register these bundles with a global bundle registration component known as the bundle table. The code on the screen is first constructing a new style bundle, and the constructor parameter, ~bundles/CSS, that's the virtual path that we can use to reach this bundle. In other words, if I add a style sheet link into my page with the href set to /bundles/CSS, what I'll get back is a single file that includes the contents of both styles.css, and bootstrap.css in that order and in a single download. That's what bundling does. It concatenates files together in addition to other things that we'll see, but the concatenation reduces the number of downloads that we'll have. Just a single download to get both CSS files into the page. You can create bundles with one or more files using one or more calls to include, and include is rather clever. Include understands a wildcard, that's the asterisk, so if you want to bundle up all the files in the scripts directory that start with jQuery-1 dot, you can do that by saying include ~scripts/jQuery-1 dot star, and the include, in addition to processing that wildcard to pick up multiple files, will also be smart enough to ignore certain files, typically files that we do want to be ignored. So let's say I've installed jQuery, and I have 3 jQuery files in my scripts directory. One is the uncompressed JS file, one is the minified jQuery file with .min in the name, and one is the Visual Studio documentation helper with .vsdoc in the name. The runtime is programmed to ignore the .min and the .vsdoc versions so that it only picks up the primary jQuery JS file, and I don't have jQuery duplicated in the download. Knowing what we know now, let's go configure the application. The first thing that I want to do in Visual Studio is configure the runtime so that bootstrap.css and styles.css can be downloaded in a single bundled file. And to do that, I'll need to add some configuration, and I'm going to add a class in the app start folder. I will call this class bundle config, and if you started a new MVC4 application from the internet template, you'd already have a bundle config and app start that has some configuration. Since we started from the empty template, there's nothing there. That's okay, we'll just add one. I want this to be in the root namespace, and I want this to be a static class. And we'll just have one method inside of here, a public static method that returns void, and we'll call it register bundles. This will receive the global bundle collection from whoever calls it. We'll call that bundles. And bundle collection is a special type that is defined in system.web.optimization. So I'll just bring that namespace into play. And now I can start configuring bundles. So let's add a new bundle. This will be a new style bundle. The path, the virtual path that I want to reach this bundle, let's call it bundles/CSS. And I want it to include from the content folder bootstrap.css. And I want it to also include from the content folder my style sheet, which is styles.css. And that would be everything that we need to build a complete bundle. Now the question is, where do we call register bundles from? Of course, that has to happen during application startup. So I will switch over to the global.asax.cs file, and inside of here we can say bundle config. Please register bundles, and I will pass in the global bundle table dot bundles property. That's the bundle collection. And bundle table, that also lives in the system.web.optimization namespace. So we'll bring that in. I'll do a quick build just to make sure everything works, and it does. So before we actually start using that bundle, let's go ahead and finish our bundle configuration. The other piece that I have in the layout view is a link to the Modernizer library. I want to create a bundle for that. And you might wonder, why create a bundle for a single file? There's nothing to combine together. Well, bundling also does minification, and I want to minify this file. We'll see what that does in just a bit. So I'll come into bundle config and say, please give me a new script bundle that I can reach by going to /bundle/modernizer and include this JS script. And this is one way to do it, being very explicit about what file I want, but I could also take the version number out of here and just say, give me Modernizer, and pick up any Modernizer file that you find in there. Because at some point, I'll probably come into my NuGet packages, and I'll find that there are all sorts of updates available. And there might be an update for Modernizer that bumps the version number from .3 to .4, and just by including --, I'll be able to pick up all those updates when I drop them into the scripts folder. I don't have to worry about changing my C# code every time I update a script file. And so in the layout view, I also have this collection of files here at the bottom, jQuery, jQuery validation, mustache, bootstrap. So let me go into bundle config and also register something for bundle/JS that includes everything jQuery, also mustache and bootstrap. So what I have here is basically telling the runtime include everything that starts with jQuery, and that should pick up the jQuery library, jQuery UI, jQuery unobtrusive AJAX, jQuery validation, and for the most part the runtime is fairly smart about ordering files. It knows that jQuery is going to have to come before something like jQuery UI that has a dependency on jQuery, but it's not always perfect. So sometimes you might need to explicitly spell these files out and say I need jQuery-1 star and then jQuery-UI star to make sure you have an explicit ordering in here. But the way these files are named, it just so happens that the alphabetical ordering will work out well. So just saying jQuery star, include everything jQuery should work out and should give me that bundle. We have all our bundles configured. We have them registered during application startup. The next part would be to start using these bundles in the layout view to decrease the page load time.